Today, Aegis Ballistic Missile Defense BMD-equipped destroyers are at sea and alert ready, providing long-range surveillance and tracking, LRS&T. Both Missile Defense Agency, MDA, and the Navy fulfill their commitment to the President's Directed Initial Defensive Capability, IDC, deploying the sea-based element of the BMD system on schedule in the 2004-2005 timeframe. With the LRS&T milestone accomplished, the Aegis BMD team prepares for testing, leading toward fielding a ballistic missile defense engagement capability. Two Aegis-equipped ships, cruiser USS Lake Erie, CG-70, and destroyer USS Russell, DDG-59, their crews, and the Aegis BMD government industry team prepare to meet the challenges of the Stellar Dragon campaign. The Missile Defense Agency, MDA, is currently building our defense against the threat of ballistic missiles, developing an integrated ballistic missile defense system, BMDS, comprised of 3 defensive layers. A boost phase defense, a mid-course phase, and a terminal phase. Today, among our potential adversaries, there is a growing military offensive capability in the form of ballistic missiles. And until now, we've had only a limited capability to stop this offense. Aegis BMD is an integral part of the mid-course phase of BMDS, countering short and medium-range ballistic missiles. Mobile and flexible, Aegis BMD places ballistic missile defense where and when it's needed at any time, providing a vital role in MDA's layered system, ready on the defense against an offensive attack. Late 2004 and through 2005, Aegis BMD is being introduced, first with long-range surveillance and tracking capability, and finally with limited mid-course ballistic missile engagement capability as part of MDA's BMDS. On the defense is Aegis BMD, the sea-based element. With the Block 04 IDC challenge of LRS&T met, the Aegis BMD team looks at its next goal, adding firepower to its surveillance and tracking capabilities with the Standard Missile SM-3.
2, 1.
Aegis BMD builds on a history of successful flight tests, the previous live firing test of the Aegis BMD system, and its SM-3 missile Flight Mission 6. FM-6 achieved the 4th successful target intercept out of 5 tests. In Moorestown, New Jersey, Lockheed Martin's Maritime Systems and Sensors, MS-2, is the Aegis Combat System Engineering Agent for the Navy's BMD Program Office. MS-2 coordinates many activities across the Aegis BMD team to ensure program success. This includes continuing development of Aegis BMD computer programs by Computer Sciences Corporation, CSC, in Moorestown. CSC programmers work along with MS-2 engineers at Lockheed Martin's Computer Program Test Site. At the Navy's Combat System Engineering Development Site, CSEDS, in Moorestown, testing of the programs was completed with an engineering assessment, EA, in early December 2004, demonstrating the effectiveness of hardware and software modifications to the Aegis combat system, supporting Aegis BMD engagement, as well as LRS&T capability. CSEDS was also the location for training Lake Erie's officers and crew in December 2004, preparing for the upcoming 2005 event. Here, officers and sailors working alongside MS-2 engineers practice engaging ballistic missiles using the new doctrine developed for the Aegis BMD mission. Rigorous analysis and planning go into developing the mission test scenarios. For the FTM 04-1 firing event, Extensive simulations of the Aegis weapon system using MS-2's Medusa program are run to verify and predict a firing solution for the test. These simulations are compared with independent analyses produced by Johns Hopkins University's Applied Physics Laboratory to correlate results. Evaluated for the first time in an Aegis BMD test is the MS-2 developed automated mission planning function called Mission Planner. Mission Planner assists an Aegis watchstander in determining the best position for the ship to operate in a ballistic missile defense area. It assists the Radar System Coordinator, RSC, by developing Aegis spy radar search doctrine and selecting appropriate spy search sector parameters for the mission. Currently, the watchstander enters Aegis and support data manually from the Mission Planner computer. In the next baseline, Mission Planner will be integrated with the Aegis weapon system. Using the Command and Decision Adjunct computer, Mission Planner will provide Aegis and spy radar search doctrine and parameters to the weapon system. In Tucson, Arizona, Raytheon's Missile System Division delivered the first of 5 SM-3 Block 1 Aegis BMD missiles to MDA on October 22, 2004.
We have an official designation of a Standard Missile 3 Block 1 as ready for fleet issue.
These SM-3 Block 1 missiles will be installed in upgraded Aegis BMD-equipped cruisers, adding a short and medium-range ballistic missile intercept capability as part of the initial Aegis BMD role. The SM-3 missile, with its kinetic warhead, KW, now in the Block 1 configuration, continues its testing, adding improvements through its block development plan. The FTM 04-1 firing is the first use of the SM-3 Block 1 missile in a test event. A meeting with members of the Aegis BMD team is in session. This meeting is the MCP, Mission Control Panel, one of the many times Aegis team members assemble to assess preparation status and address any issues before a test can proceed. Admiral Kathleen Page, the Aegis Ballistic Missile Defense Program Director, opens the MCP with recognition of the team. The word from the MCP? The test is a go. FTM 04-1, the flight test mission phase of the Stellar Dragon campaign, is on. WIT is the Waterfront Integration Testing time period before a firing test begins. Much preparatory work occurs throughout the WIT period, in port and during sea trials on cruiser USS Lake Erie and destroyer USS Russell, including equipment installations, readiness assessments, and test support equipment, concentrating on system integration, installation, and checkout of the new Aegis BMD 3.0 configuration, including functional testing, system and auxiliary testing, and crew training. One event planned during WIT is the tracking of a live Aegis Readiness Assessment Vehicle, ARAV, during the Stellar Dragon Tracking Exercise, or TRACX. 31 January 2005. Lake Erie and Russell depart Pearl Harbor, Hawaii for a 4-day sea trial. Sea trials give both ships and crews the time to rehearse and practice before the FTM 04-1 firing event. It also gives the Aegis BMD test team time to check out their test and data gathering equipment. 3 February, Aegis cruiser Lake Erie with the new Aegis BMD 3.0 weapon system providing operational missile engagement capability, and the Aegis destroyer Russell equipped with a state-of-the-art Aegis BMD signal processor test bed are on patrol off the Hawaiian island of Kauai. Russell's Aegis BMD signal processor, BSP, tests advanced waveforms that support lethal object discrimination and classification functions for future Aegis BMD Block 06 development efforts. The test bed also improves track resolution on principal objects and provides wideband discrimination and feature extraction. On a Pacific Missile Range Facility, PMRF launch pad, is an ARAV-A ballistic missile test vehicle, a Terrier Orion Group A threat representative sounding rocket, the first live ballistic missile to be tracked by the BMD 3.0 weapon system. Another objective of TrackX is gathering data evaluating the ARAV-A as a potential ballistic missile test vehicle for future test and training events. As Aegis BMD deployment progresses, Stellar Dragon's tests are conducted with increasing war cruise realism for each event. Ship's officers and crew are given an intelligence overlay for each scenario for operations in a war cruise environment. Intelligence from 3rd Fleet Commander assigns Lake Erie and Russell to perform a TrackX data collection mission on Radical Regime Country Red, which has announced test launch of a missile near friendly Country Green. Aegis ships provide support for our ally with U.S. presence. Russell is positioned closer to the expected target launch point and will detect and track the ARAV before Lake Erie. Officers and crews of the ships don't know the exact launch time of a hostile ballistic missile. They have to be ready to perform a simulated SM-3 engagement after target detection. Russell detects the ARAV ballistic missile seconds after launch with its spy radar and begins advanced discrimination processing and data collection for Block 06 risk reduction. As the ARAV climbs in elevation, Lake Erie detects and tracks it with spy.
Fireball, 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 track number 1325.
The ballistic missile doesn't fly a nominal target trajectory and isn't engaged by Aegis BMD.
Control MSS, I'm reading unengageable here for the target.
He's got an unengageable.
A primary system objective of the TrackX is to verify Aegis BMD engagement processing capability with the new 3.0 engagement weapon system, using either a cue from an external sensor or exclusively onboard systems. The Aegis weapon system, AWS, determines that the ballistic missile does not meet target criteria and does not execute a simulated SM-3 engagement as expected. Also important is how well the operation of BMD's voice and data communication links work under current instructions and directives.
Stand by for amplifying data. Out.
AWS forwards track data, launch point, impact point, and engagement status to keep other BMDS elements notified of the ballistic missile's engageability.
In all stations, Crater, track number 1321.
Although Lake Erie fires no live SM-3 missile, TrackX gives the opportunity to conduct simulated SM-3 engagement processing against the ARAV ballistic missile. At the conclusion of the TrackX, ships, crews, and the Aegis BMD team head back to Pearl Harbor with a sense of accomplishment. Operating in a war cruise environment, they successfully detected and tracked the ARAV ballistic missile, gathering data for future analysis, and exercised BMDS operational communication links in an Aegis BMD 3.0 engagement configuration on Lake Erie. One more stop for Lake Erie. Lake Erie pulls into Weapons Station Naval Magazine, Pearl Harbor, where an SM-3 Block 1 is loaded into the aft Mark 41 vertical launching system, VLS. Inside this canister is the SM-3 missile, which will be fired during FTM 04-1, the next major event of the Stellar Dragon campaign. There are never two ballistic missile defense tests quite the same, nor are they meant to be. Testing new capabilities, new equipment, different threat scenarios. A lot of work goes into the preparation of a Aegis BMD flight test. It certainly holds true for FTM 04-1. This is the first flight test mission using the Aegis BMD 3.0 weapon system. The BMD 3.0 weapon system is the first Block 04 program which adds Aegis SM-3 firepower to its existing LRS&T capabilities. Lake Erie is the first Aegis-equipped cruiser which will introduce this capability as part of Block 04. Also, the SM-3 Block 1 missile, with added discrimination capabilities, is being exercised for the first time in a flight mission against a Target Test Vehicle, or TTV, with a flight trajectory consistent with potential missile threat targets. It's the first flight mission exercising a one-pulse option of the third stage rocket motor, or TSRM. The TSRM is capable of up to 2 pulses to push the SM-3 third stage higher and faster. Since the TSRM's second pulse is not needed against this TTV, the Aegis BMD 3.0 configuration will direct the TSRM to fire only a single pulse burn. And FTM 04-1 marks the first operational use of Aegis Auto BMD doctrine missile engagement. With Auto BMD doctrine, the Aegis system automatically computes a recommended time to fire and engage the target with an SM-3 missile. Aegis is capable of firing the SM-3 automatically, but as part of the firing loop in this test, the Aegis BMD system will alert the Missile System Supervisor, MSS, when to press the fire key. After undergoing a 2-week Navy tactical training and certification period, officers and crew of Lake Erie are ready for action. Also participating in FTM 04-1 is USS Russell, gathering test data demonstrating for the first time the capabilities of the new Aegis BMD signal processor, or BSP. BSP provides improved track resolution and discrimination feature extraction in real time. In addition, BSP tests advanced waveforms that support lethal object designation and classification for future Aegis BMD block upgrades. 21 February 2005. USS Lake Erie CG-70 and USS Russell DDG-59 with their officers, crews, and Aegis BMD test team depart Pearl Harbor, Hawaii for the Pacific Missile Range and the FTM 04-1 firing event. At their battle stations, as conducted in past tests, our officers and crew assigned to in-service Navy combat ships USS Lake Erie and USS Russell, executing this flight test mission. Stationed off the Hawaiian island of Kauai is the firing ship USS Lake Erie. Receiving an intelligence report, Commander 3rd Fleet assigns Lake Erie and Russell to perform active BMD defense of Ally Country Green. Lake Erie is maneuvering in its assigned operational patrol area. The crew is at space warning condition yellow readiness, awaiting a hostile ballistic missile firing. Extensive optical sensor and radar systems, video, audio, film, and instrumentation data is on station to document and collect engineering data to assess system performance. The video and audio displayed is from actual testing data. After a series of increasing threat levels, Lake Erie and Russell receive their latest intelligence reports, set space warning red, weapons tight. They are at the highest stage of alert for a ballistic missile launch. They will get no countdown. They have to be ready to react to hostile actions and detect a possible threat launch. Lake Erie's RSC uses Mission Planner for the first time, the automated mission planning function, assisting in developing spy radar search doctrine and setting up search sector parameters. On the Kauai Test Facility launch pad, an Ares TTV ballistic missile target undergoes final countdown.
9, 8, 7, 6, 5, 4, 3, 2, 1.
Knowing where to direct Spy 1 radar search volume is important for early target detection.
Fireball, fireball, fireball. Track number 1310.
A side-mounted video camera on the TTV provides a unique view as it climbs above the atmosphere and into space. Aegis Spy-1 radar and Lake Erie and Russell detect the target as it breaks the radar horizon, while still in its boost phase. Seconds later, Lake Erie transmits the TTV track information over Link 16 back to the Ballistic Missile Defense System BMDS. After the set space warning Red Weapons Free is announced, Lake Erie's commanding officer authorizes the vertical launching system in preparation to fire.
All stations, Captain, batteries release, fizzes green.
Spy-1 radar transitions to target track, and precision information is distributed to the Aegis weapons system. Shortly after target booster burnout, Spy-1 radar processing determines that the target is in its ballistic flight phase, and the Aegis system declares the TTV track as engagement quality. For the first time, the target is processed automatically for engagement by the Aegis system in the Auto BMD mode. In previous flight missions, the Combat System Controller, CSC, would manually start the engagement sequence. The Aegis weapons system initiates the engagement order to the Missile System Supervisor, or MSS. Upon receiving a recommend fire alert, MSS presses the Fire Authorization Variable Action button, VAB.
Authorized.
Prior to launch, the SM-3 missile is initialized with GPS data and position and velocity data for the target and the missile. Shortly after SM-3 launch, the Spy-1 radar system acquires and tracks its SM-3 missile.
All stations, Captain, fizzes red.
Control I.
Acceleration commands are computed by the Aegis weapons system and transmitted to the SM-3 missile via spy radar uplink message data, keeping it on a target intercept path. As the SM-3 flies toward the target, three important steps occur. The second stage burns out and separates. The Aegis weapons system updates the missile with both the missile's and the target's position and velocity data. And for the first time in a flight mission test, because of the target flight path, the Aegis weapons system gives data commands to the SM-3 missile to perform only a single pulse burn. While coasting, the missile performs a pitch maneuver, safely ejecting the nose cone, while maintaining a collision course on the target. The third stage attitude control system orients the missile so that it points at the target. Before the KW is ejected, the Aegis system gives Phase 3 uplink information to the TSRM, providing the SM-3 with Aegis target and object track data by way of a target object map, or TOM. With spy radar accuracy, the Aegis weapon system is able to put the target dead center in the SM-3's field of view, following a single pulse TSRM burn. After ejection from the third stage, the KW acquires the TTV. The KW, using its infrared IR seeker, correlates its tracks to those received in the TOM from Aegis to discriminate the target from other objects, quickly driving the KW to the target with divert guidance. The square around the target image indicates that the target is now in track and KW divert guidance has commenced.
Bye-bye. Got it.
It's a direct target hit.
Marking you.
The target's payload area is destroyed.
Yes.
The KW impacts the TTV at the desired aim point. Another intercept for Aegis BMD. FTM 04-1 provides important data gathering opportunity from a variety of optical sensors and radar systems, clearly showing the lethal TTV destruction by the Aegis SM-3 missile. This slow-motion replay of the target impacted by the KW is recorded by the Halo 2 airborne system, showing the SM-3 third stage and nose cone. Here is the KW, and here is the Ares TTV. The explosion is evidence of the KW impacting the target with its reactive payload. In addition, Russell's Aegis BMD signal processor, BSP, performs real-time high-resolution tracking and discrimination feature extraction. BSP also collects valuable data for kill assessment advanced algorithm development. This is the first at-sea use of Aegis BSP in a flight mission event. Also tested is the Aegis Kill Assessment and the Missile Downlink System testbed, used to evaluate the intercept. A number of firsts are achieved at the completion of FTM 04-1. But perhaps the best is, now Aegis BMD engagement capability is a reality. Around the country, the test's success is seen watching the event live over Lake Erie's and PMRF's video conference link. The Aegis team is ecstatic with the visible test results. But the conclusion of FTM 04-1 doesn't complete the Stellar Dragon campaign. ASD is only days away. Capping off the Stellar Dragon campaign is At-Sea Demonstration 3.0, or ASD 3.0. ASD's 4 planned events occur over a 3-day period the first week of March. System-level objectives are similar to earlier Stellar Dragon events. Verify Aegis BMD engagement sequences. Evaluate BMD's performance against the engineering specifications. That is, can Aegis BMD do what it is designed to do? And assess important BMDS voice and data communication links and procedures in an operational environment. Besides verifying and exercising these system-level objectives, ASD's purpose is to find out and evaluate how Aegis BMD 3.0 performs in a multi-warfare environment, testing ship self-defense capabilities in a ballistic missile defense configuration. In other words, what else can Lake Erie with its officers and crew do in its BMD configuration? 3rd Fleet provides the needed naval forces to test Lake Erie with its Aegis BMD 3.0 weapon system loaded. As in earlier Stellar Dragon events, ASD has an intelligence overlay associated with each test. Commander 3rd Fleet assigns Lake Erie and Russell the job to maintain critical open channel sea lanes between Country Red and Green, while providing active BMD defense of Allied Country Green. In Event 1, USS Lake Erie operating in Aegis BMD 3.0 configuration and USS Russell in non-BMD Tactical 5.3.8 patrol the sea lanes between countries Red and Green. A simulated Group A ballistic missile track, a dynamic test target or DTT, is launched and Lake Erie acquires and tracks the target.
Fireball, fireball, fireball. Track number 80452.
Control Captain, say track number.
1044, sir. Attack control, auto engagement ordered.
Fizz green.
All stations tag, Fizz green.
The ship relays track information back to BMDS. An attack submarine and high-speed maneuvering surface targets, or HSMSTs, representing small attack patrol boats, are patrolling the vicinity. Lake Erie makes sonar contact with the submarine.
Sub sonar. Sonar has passive narrowband contact.
With the patrol boats attacking, Lake Erie engages the small boats with its 5-inch gun.
Gunlay set.
Yes, sir. Just reporting.
Batteries released.
HSMST. Rapid and continuous. Ceasefire. Ceasefire. Guns copy. Ceasefire.
Lake Erie maintains track on the DTT and sonar contact with the submarine.
Sonar has new passive narrowband contact, designated tag number 4, bearing 063.
Additionally, both ships simulate Harpoon anti-ship cruise missile engagements against the target patrol boats. In Event 2, Lake Erie and Russell receive new intelligence on a possible threat launch and transit to new surveillance stations. Lake Erie remains in Aegis BMD 3.0 configuration, conducting a surveillance mission in preparation for a ballistic missile launch. An ARAV-A ballistic missile is launched from PMRF, and Russell acquires it as it breaks the radar horizon. The Aegis weapon system detects an incoming BQM and identifies it as a hostile air target. Russell, still in a 5.3.8 configuration, launches an SM-2 Block 3 missile. Engaging and destroying the AAW threat. In addition, Lake Erie demonstrates the ability to track DTTs in a jamming electronic warfare environment.
And EW TAC, cease jamming track 2071.
As day one ends, the Aegis combat system demonstrates its ability to perform a BMD mission in a multi-mission environment. On day two, in Event 3, a hostile submarine is reported in the vicinity of Lake Erie and Russell. Reports indicate an imminent launch of a second threat launch. LAMPS is deployed from USS Lake Erie to find and maintain contact with the submarine. The threat, an ARAV-A, is launched from PMRF. Russell, running the Aegis Ballistic Missile Defense Signal Processor 1.0 testbed, detects and tracks the threat into its ballistic missile flight, collecting valuable engineering data for future Aegis BMD development efforts. A Mark 48 torpedo is reported inbound toward Lake Erie. Lake Erie and Russell execute evasive torpedo maneuvers, respond with over-the-side torpedo attacks, and direct aircraft and helicopter attacks on the enemy submarine while maintaining their BMD configurations. As Day 2 concludes, Commander 3rd Fleet assigns Lake Erie and Russell new surveillance positions to counter another possible ballistic missile threat launch. Intelligence indicates this new threat is more challenging. The ships transit overnight and await the impending launch. The fourth and final event of ASD 3.0 is on Day 3. An ARAV-B Terrier Oriole medium-range ballistic missile is launched from PMRF. Russell, operating its BSP testbed, detects the target and performs real-time high-resolution tracking and discrimination feature extraction on the separating target objects. The BSP testbed also collects valuable data for advanced algorithm development for future Aegis BMD block upgrades. Lake Erie obtains track of the ballistic missile.
Fireball, fireball, fireball. Track number 1031.
Batteries released for a manual shot.
Captain Attack Control, engage with SM-3.
Eagle away, 1031.
Lake Erie performs a simulated engagement on the separating ballistic missile. After tracking the ARAV-B, Russell conducts a simulated Tomahawk strike against Country Red. At the completion of Event 4, Lake Erie, Russell, their officers, crews, and the Aegis test team return to port in Pearl Harbor. With ASD finished, the 2005 Stellar Dragon campaign is complete. Stellar Dragon campaign, the most rigorous at-sea ballistic missile defense testing to date, is over. But what we learned from it has only begun.
A lot of firsts and an awful big chance to display to the Navy and to the nation just how good the crew of Lake Erie can be when given awesome technology.
The Secretary of Defense said while we are beginning to bring ballistic missile defense out of the engineering laboratories and into the real world,
getting it out there, playing with it, working with it, testing it, evolving it, learning about it, showing people what it can do, learning what it can do and what it can't do. That isn't rush to deployment, that's rush to learning.
These words mirror a proven Aegis standard. Build a little, test a little, learn a lot. Guarding our nation, our armed forces, and our friends, we're Aegis Ballistic Missile Defense, and we deliver.